Hey, dude, we gotta help me with my math project. Hold the camera.
Oh, hey, what's up, Mac? I was just looking at partial differential equations, which are multivariable functions that relate a function in one or more variables. For instance, u of x t, for every t, there is a different u of x.
Well, I don't care about that. You gotta help me with my heat equation.
Okay, dude, calm down.
Take the camera. We're gonna do the heat equation, kids.
Alright. Where's the button on this?
See, this is hot as car is hot. Only we had like a sort of equation that can determine how heat dissipates through a surface over time.
Oh man, that'd be pretty useful right now.
So we're gonna talk about here in the car.
All right, let's go.
Hey,
Don't look.
okay, so what a lot of people don't know about the heat equation is that it's a partial differential equation. Talking about physics, and talking about partial differential equations. So the heat equation, you see, if you look here, you'll see the equation. You see the equation. It has. You'll notice that there's a little thing right there. It's like, what is that? Alpha, and who cares? It's actually a constant of thermal diffusivity, which different materials will diffuse heat at different rates. So that's what that's for. Okay, so there you got the second partial derivative with respect to x, which is going to tell you, like, they give you the function of x for every t to show you how heat dissipates through it. That's what the heat equation is. That's what we're going to figure out today. So I says to her, that's amore, But anyway, back to the heat equation. So what you'll notice about the heat equation is that it's actually a boundary value problem, which means that it's got these boundaries. Here they are now. All right. All right. Here's the boundaries now. So the first boundary, that's the initial. It shows the initial formula where the heat's distributed initially, which in one-dimensional graph will be shown on the y-axis. And then the two other boundaries here show the set temperatures at different ends. Right now it says they're 0, which means at each end it'll be set at 0. So like with a hypothetical rod, each end would be at 0 degrees. That's how the bounds work with the heat equation. Who actually listens to Slipknot anyway? It's a lot of people. They use the heat equation every day in work. All right. They use the heat equation in Chick-fil-A. All right.
Here's your water.
Thank you.
And there's your sandwich there.
Thank you.
Apparition's fire. We desire agony, expose the ground flesh.
You know what? Notice my sandwich, now I took a bite, it's a crescent shape. Now if this was 2D, and we represented heat for this hot Chick-fil-A chicken sandwich, that represented heat for height, it would look a bit like this. Okay, so now if it was 2D, just a completely 2D object, and we're representing heat like that, in uniform heat across this hot, delicious Chick-fil-A sandwich, you would see, as time goes on, as T increases, the corners are the ones to cool off first, while the center remains hottest because it's surrounded by heat. And that's how diffusion works, and that's what the heat equation shows us. Put up the heat equation again. Move it off my face. Hey, can you grab me a mint? Grab me a mint.
Oh, alright.
Gotcha! It's on, man. It's ketchup. Idiot!
Wow, I'm learning so much.
Heat equation. This adventure, I'm really starting to understand more about the heat equation and what it means to the world around us. Just think a bit about heat, like this hot this hot nickel right here. And it gets colder. 0 temperature, that's what the heat equation tells us. And that's what we learn from the world around us.
Boy, I learned a lot about the heat equation today. This is my stop, so...
I learned a lot about the heat equation too. I hope you viewers did at home. Any questions? No? Okay, give my camera back. That was probably good.